Hi guys, welcome to my series on calculus. We're going to start off with first principles. If you don't know anything about calculus, first principles is probably the most important thing. If you don't know it, it's probably going to hinder you from knowing a lot of other stuff, and it also underpins the use of the other stuff. So what is first principles? Well, it's a formula that allows me to find the gradient at any point on a function. Now, obviously if I look at this function, as it goes around, the gradient is changing. For instance, where I've drawn this last arrow, we've got a negative gradient. But when I draw this new arrow, I've got a positive gradient. So I can't just have a constant no more, like we did with y equals mx plus c. That was our straight line. So what I can do is, I can either draw a tangent, not really that useful. What I'm going to do is I'm going to draw on 2 points. So something like this. I'm going to name one of these points x, so it's a coordinate, an x coordinate of just x. The other one has an x coordinate of x plus h. You'll see why I've chosen this in a second. Now, what I can do is I can join along here, and join along here its corresponding y coordinates. But how can I find them? Well, I'm going to say y equals a function of x. It's some function of x. Now, what I can do is I can find a gradient of this line, and I know it's not going to give us a good representation, but I can find a gradient of this line, and I'm going to call that f prime of x. That's my gradient function. So what is f prime of x? Well, f prime of x is going to be equal to, well, it's going to be our change in y over change in x. Well, that's going to be f of x plus h, because that's our y coordinate here, minus the other y coordinate, which is going to be f of x. We don't know what the actual values are going to be. Could be anything. And this is going to be divided by our x coordinates. So we're going to have x plus h, that's the corresponding x coordinate, minus x. Now hopefully you see the x's cancel. So we're going to be left with f of x plus h minus f of x over h. Now you're going to notice this is quite a useful formula, but this gradient is clearly not it's clearly not the gradient at that point. Now what I can do is, as I get the point x plus h closer and closer to x, my secant, as we like to call it, is going to be more and more accurate to the curve. And you can see I've drawn one here. It looks almost succinct with this curve. So what I can say is, what happens is h basically becomes 0. Now it can't be 0 because it'd be on the point, but what happens is it goes towards 0, and we can use this little notation. The limit as h approaches 0, and I'm going to add this here as well, and this is our first principles formula. So f prime of x, which is our gradient function, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Thanks for watching. In the next video we'll apply this formula.